Good afternoon to all of you. I'm Rajesh Kumar, science teacher of Pratapgarh School, Pathankot. Our main chapter is metal and non-metal, class 10 chemistry. This is the third lecture. Okay, let's start. First topic is ionic compounds or electrovalent compounds. Ionic compounds are those compounds which are formed by the transfer of electrons between metal and non-metal. Okay, these compounds are basically involve one metal and one non-metal. For example, NaCl, KCl, copper sulfate, calcium sulfate, copper chloride. These all are ionic compounds because these compounds are formed by the ionic interaction between oppositely charged atoms. Okay, for example, you take an example of NaCl. Okay, when you dissolve NaCl in water, the Na having positive charge and Cl having negative charge. Okay, and the interaction between these two atoms are called as ionic interactions. Okay, the properties of ionic compounds are very strong compounds. They require large amount of energy to break these compounds. So we can say that they have high melting point, they have high boiling point, they are soluble in water but insoluble in organic solvents. And most important thing, ionic compounds can conduct electricity in molten state, or when you dissolve these compounds in solution in solvent. Okay, then they can conduct electricity. Okay. Metal now main topic is occurrence of metal. Okay, then the extraction of metals. Okay, metal, what is metal? We know that metals are hard, you know? We know that the properties of physical property or chemical property of the metals, metal reactives, metal can conduct electricity, metal can conduct heat. Okay, this is the property of the metals. Okay, see, extraction of metal is very important topic according to the board point of view. Okay, some metals like gold, silver, platinum are free state. Why they are present in free state? Because these metals are least reactive metals, and high reactive metal like sodium, potassium, these are found in combined state. Okay, these not present in free states. Okay, minerals, what are the minerals? Minerals are those compounds which occur naturally inside the earth crust, or you can say that the minerals are those compounds which are present in earth crust and which require for the growth directly or indirectly. Iron, magnesium, calcium, potassium, these required by a body for the growth and development. Okay, ore is a substance from which the metal extracted, from where we extract the metals. Ore is a mineral from which metal can be extracted. Okay, gangue is impurity. Gangue actually impurity. We know that metals are not present in pure form in earth crust. Okay, we need to extract that metals and we need to separate the impurities from the metals. The impurity is called as gangue. Okay, now extraction of metals from the ore. Okay, there are three main steps. By using these steps we can extract the metals from ore. Concentration of means enrichment of ore. Okay, reduction of metal. Reductions are those reaction in which we can remove the oxygen group, O group. For example, magnesium oxide. magnesium oxide Magnesium oxide is an oxide of metals. Okay, we need to remove the oxygen, and this particular step is known as reduction. Okay, then refining, then purify the metal. Okay, first is concentration is, or means removing the gangue, removing the impurities by different methods. Okay, now this is a flow chart of the extraction of metals of high reactivity, metal of medium reactivity, metal of low reactivity. Metal of high reactivity means the metals which are highly reactive metal like sodium, potassium. Okay, the metal of average reactivity, for high reactivity we use electrolysis. For medium reactivity we use carbonate or calcination and roasting. Okay, calcination and roasting are very important. Okay, metal of low reactivity, for low reactivity we also use roasting. Okay, first we study about electrolysis, then calcination, then roasting. Okay, this is a chart, this is a very important chart. Extraction of metal of low reactivity, low inactivity series. Okay, means a low reactivity. Okay, we know that for low reactivity we use roasting. See, roasting and calcination, these are two process which basically use for extraction of reactivity, medium reactivity. Also the metals of medium reactivity, for metals of medium reactivity we also use calcination and roasting. Calcination is a process which used for carbonate ore. C for calcination and C for carbonate ore. Okay, carbonate ore, for carbonate ore we use calcination, and for sulfide ore we use calcination, we use roasting. Okay, roasting basically used for the sulfide ore. For example, there is an example of ore cinnabar. Cinnabar is a mercuric sulfide. Okay, cinnabar is a name of a ore of mercuric sulfide. So Hg is a mercury and a sulfur. See, Hgs, mercuric sulfide. So mercury this cinnabar is a ore of sulfide. So sorry, this mercury, this cinnabar is a sulfide ore of mercury. Okay, now for extraction of the mercury from that ore we use roasting. Okay, roasting is a process in which we use excess amount of oxygen. For example, HGS plus 3 oxygen, heat, then oxide of metals are formed, mercuric oxide, then we go for reduction. Okay, in the reduction I already discussed with you what is a reduction. Reduction is a removal of oxygen. Mercuric oxide, then we heat the mercuric oxide, it gave us mercury and oxygen. Okay, now this is a process, this is actually a roasting process. Okay, then again there is another example of copper oxide, because again sulfide or sulfide, copper sulfide, then roasting, again copper sulfide plus oxygen, then we heat up the this reactant, then they give us copper oxide and sulfur dioxide, then reduction. Okay, and so on. Now then the second one is, see, roasting is same. We use you use whether sulfide, for zinc sulfide, for mercury sulfide, or any sulfide. For all sulfide we do roasting process. Okay, but for carbonate ore we use calcination. Okay, see, calcination and roasting both are same, but there are some difference. In case of calcination we use limited supply of oxygen. Okay, but in case of roasting we use excess amount of oxygen. Second, during reduction in roasting, during reduction in roasting we use only heat, we use only heat. We heat the metal oxide, and metal oxide give us metal and oxygen. Okay, will show you this one. Okay, see, mercury oxide, we heat the mercury oxide, it gives us mercury and oxygen. Okay, but in case of calcination, first we use a limited supply of oxygen, then during reduction process we use a reducing agent. Carbon is a reducing agent. For example, take an example of zinc sulfide. Okay, zinc sulfide, oh sorry, zinc carbonate. Okay, take in calcination, take example of zinc carbonate. Okay, zinc carbonate, when you heat up the zinc carbonate, it gives us carbon dioxide and zinc oxide, then reduction, zinc oxide plus carbon. Carbon is used as a reducing agent. The oxide ore is then reduced to the metal by heating with the reducing agent. The carbon is used as a reducing agent. Okay, it give us zinc and carbon monoxide gas. Okay, see, then other difference between roasting and calcination is, in case of calcination the two main gases are formed during the process, carbon dioxide and carbon monoxide. But in case of roasting, the two gases are formed during the process is, first one is your sulfur dioxide. Okay, and the second one is oxygen. Okay, sulfur dioxide and oxygen. Okay, sulfur dioxide and oxygen. Now last one is thermite reaction. Okay, thermite reaction, as the name indicate, thermite reactions. What are the thermite? Okay, before thermite reaction we can discuss about electrolysis, electrolytic refining. Okay, electrorefining. I hope in next lecture we discuss about electrolysis. Okay, I hope you understand all this concept. These reactions are very important: extraction of metals, calcination, roasting, thermite reaction, electrolysis. These are very important. Okay, according to the board point of view. Okay, extraction of metal means we extract the metal from the ore. Ore is a substance from where we extract the metal. Gangue is a impurity along with the metals. Okay, and we have three divisions, or we can divide the metals on the basis of their reactivity in the three groups: the metal with high reactivity, one group; the metal with medium reactivity, second group; and the metal of low reactivity, least reactive, in the third group. Okay, for high reactivity metals we use electrolysis. Electrolysis means electro means current, and lysis means breakdown. We break the salt, we break the compound, and these compound give us ions. Okay, and then we can separate on the basis of their charge. Okay, then for medium reactivity we use calcination and roasting. Calcination, C for calcination, C for carbonate. Calcination is basically used for the carbonate ore, and roasting is basically used for the sulfide ore. Okay, and low reactivity, for low reactivity we also use roasting. Okay, I hope you understand all this concept. If you feel any problem, you can call me, or you can ask me any doubt, any question during the class. Okay, now thank you, meet you soon in the next lecture. I hope you understand all this concept. Thank you and have a nice day.